What this is leading to is a good discussion about how tri-substituted benzenes are synthesized. So we're going to use the process of retrosynthesis to plan a synthesis by working backwards from the target. So you'll always be given a target. The target is our final product. That's what we end with. Okay? That's the thing that we want to get. So if this is our target, meta-bromo-nitrobenzene, and I want to synthesize that, say, let's synthesize all of these from just regular benzene. What I do is work backwards, okay, thinking what the last thing is that would make this compound. What's the compound that comes right before this? Or what's the last reaction that has to happen to make this one? So I have a bromine and a nitro group that are meta to each other. So the last thing that's added has to be added when there is a meta director already on the ring. Okay? Remember, that's so important. Where something is placed is not a function of the compound you're adding. Okay? The things you're adding are just electrophiles. Okay? One electrophile is not really different from another electrophile. However, what's already on the ring is what directs the electrophile to add in certain places. So if these are meta to each other, I need to have, in my last step before this, here's a retrosynthetic arrow. That means comes from, I'm going to say this meta-bromo-nitrobenzene. Let's just think about this in each case. If I had just bromobenzene, okay? Imagine this nitro group isn't here. Okay? Sort of cover it up like that. If I had bromobenzene and I wanted to nitrate it, since bromine is an ortho-para director, the nitro group would go ortho or it would go para. Okay? So that won't work. This molecule has to come from nitrobenzene, because nitro group is a meta director. If my last step is brominating, the bromine will be added meta to that nitro group. Okay, so then of course nitrobenzene can come from regular old benzene by just a nitration reaction. So that's our retrosynthesis. You'll probably also be asked to write a forward synthesis. The forward synthesis will start with the compound you were told to start with, in this case, benzene. Forward synthesis always shows the reagents. Okay? Remember, retrosynthesis is not something that you do in the lab. Retrosynthesis is just us planning on paper, working backwards what compounds we had as intermediates. Okay? The forward synthesis is what we actually will do in the lab. I'll start with benzene. I'll add HNO3 and H2SO4. Benzene will be nitrated. Okay. Whatever the next reaction is, whatever I add next will go in the meta position because nitro is a meta director. So if I add Br2 with FeBr3, I will get our product. Here's nitro, here's a bromine that is meta to it. There's our target. Okay, so the trick to this is maybe just taking and covering each of these up with your thumb and thinking if I cover up this nitro and I have a bromine on that molecule, where would a electrophile go? Okay, and bromine would direct things ortho or para. That's not what we want. If I cover up this bromine and I have a nitro group on the molecule, that nitro group will direct things to go meta. So that's what we want. So that's the gist of retrosynthesis. It's just planning in your head or on paper what the last thing was that was added. Okay? In this case, the bromine is the last thing added. And then figure out where the substance came from before that. So say I've got this compound. I've got meta-bromo aniline. Two groups that are meta to each other. The problem is both bromine and NH2 are both orthopara directors. So there's no sequence of adding a bromine and we don't even have a reaction to just add an NH2. So there's going to have to be some kind of functional group change. If we recognize that if I had a nitro group on the molecule, I would be able to add a bromine meta to it. We know that nitro groups can be reduced to amine groups, to NH2. So if I do retrosynthesis, I know that this NH2 can come from, here, let's do purple. We can make an NH2 group out of a nitro group. That will allow the bromine to be put on. So that comes from just nitrobenzene, and that comes from just regular old benzene. So that's sort of our key here. The nitro group becomes the amine in the very last step. Okay? Before that, the nitro group allows the bromine to be attached, and then before that, we can put the nitro group on. Right? So just doing our regular forward reaction will look like this. Let's start with benzene. Let's start this one just like the other one. HNO3, H2SO4, making nitrobenzene. Then brominate, Br2 with FeBr3. That will put a bromine meta to that nitro group. Finally, last step, H2 with palladium will convert the nitro into an NH2. There is our target. So that was a nice 3-step synthesis. Key to this is recognizing you have two groups that are meta to each other, so there had to be some meta director present on the ring at some point. We know a nitro can be turned into an NH2, so that was our last step. This NH2 came from a nitro. Okay? That came from just the nitro compound because putting the bromine on could occur there, and then that could come from just regular old benzene. So here's a couple of 4-step syntheses. If you have not tried these yet, stop this playback right now. Spend some time, try to get something on these. If you get stuck, you can start playing a little bit. You'll see what at least the first part of the retrosynthesis is. So make sure to try these. Just watching me do this is not going to let you be able. It's not going to make you be able to do synthesis. Okay? Synthesis comes from you practicing with a blank sheet of paper on a problem that you haven't seen before. So stop me right now if you haven't tried this yet.